Hello, everybody. This is the second Jupyter Notebook recorded video that we're doing. And again, I encourage you to have the notebook open, follow along, make sure you're understanding what's going on at each step. And if you're a little confused, pause the video, try it out, make sure you understand before moving on. In this notebook for this week, it's the first of two in the pre-recorded videos, we're going to be talking about data files in Python, introducing how to start working with different types of files in Python within Jupyter Notebooks. And we're going to introduce pandas, which is a package we'll be using throughout the course that you'll have to get very familiar with. We'll touch a little bit on web scraping and APIs at the end and discuss working with data. So typically at the beginning of Jupyter Notebooks, you'll have your setup. Here, your default in your notebook is probably already set so that anything plotted will be in line. This is a magic command, just ensuring that that's the case. So your default probably already takes care of this. This will just make sure that any figures that we create show up within our notebook. We'll be using Pandas and NumPy. Pandas is the core of working with data frames, which we'll see in a second. It is almost always imported with the short name PD. So that anytime you have to refer to a function from the Pandas package, you can just use PD. NumPy is helpful for working with arrays. So whenever you have homogeneous data stored in an array object, so rows, columns, all homogeneous, you would use NumPy, and that's almost always imported as NP. So after we run this cell, we're ready to start talking about data friendliness. This is about what types of files are easier to work with. This should sound familiar as we've talked about this previously when we were talking about semi-structured, structured, and unstructured data. So data are friendly when they are easily used in data analysis. So these should look pretty familiar here. The friendly file types are things like CSVs, which we talked about previously. TSVs are tab separated value files. So instead of a comma separating each column, these have a tab separating each column. JSON and XML we've talked about before, and then TXT files are also flat files that are pretty friendly and easy to work with. Unfriendly file types are basically any files that are made to look nice for humans. So these are things like PDFs, Word documents, HTML being displayed on a website. These are very visually appealing, but they make it hard to analyze data from. Not impossible, but more difficult. To review, CSVs are comma-separated value files where each value is separated by a comma, and you can think of them much like a list in Python or a whole bunch of lists next to one another. And there is a way to see the information stored in a file. So here we're going to use cat. Anytime you see the bang or the exclamation point to start out a line, this indicates that I'm running a shell command. So it's going to the shell. So rather than running Python here, we're running a bash command, shell command. So we're going to say cat, and then we're going into the path data and looking at the dat.csv file. So we can see what the raw CSV file looks like. So no formatting here. Different observations, different rows are separated by new lines, and each column is separated by a comma, right? So this is the structure we've seen before for CSVs. There is a module devoted to working with CSVs. I'm going to go through this somewhat quickly because you likely will not use this in the course. I just want to introduce each of the pieces to get us to where we're going. So you can import that module. And you can see the code for opening and reading a file with the CSV module. This is what we had to do before Pandas came out in the mid-10s. So you have to open it, you specify how you're going to open it, what you're going to call it, then you use CSV reader. Note this comes from the CSV module, specifying the delimiter is a comma, and then go through each row and print that. So we can use Python and the CSV module to read in the information from that file. However, what's going to make your life a lot easier is the fact that the Pandas package exists. The Pandas package will be what we use extensively for analyzing and working with data in Python. It was developed by Wes McKinney, and it has really helpful functions like read CSV. So if we look here, you can see that there's the read CSV function here in the documentation, and you can see that there are a ton of parameters. Now, most of the time, the defaults will work pretty well, but you can see that there is a lot of flexibility within the Pandas package. This makes it very flexible in use, but somewhat harder to learn because there are so many parameters, so many functions. It's a very helpful, a very extensive, and a very flexible package. So we'll be learning bits and pieces throughout the quarter. You'll get very familiar with certain functions like read CSV, and you'll have to look up some throughout the quarter and realize just how extensive Pandas is. The docstring here says read CSV file into a data frame. So the data frame is going to be the core piece of the Pandas package. So rather than using all of those, 5 lines to read in a CSV file, we can accomplish the same goal just using the read CSV function from the Pandas package. So we pass it the file path and the name of the file as a string, and here we're specifying there is no header. When we do this, we read the information in, but note that it is no longer just displaying separated by commas. Pandas in a Jupyter notebook displays the information using row indices. So we've added in 0, 1, 2. And if header were not none, our column names would be here. When header is none, it just gives you, again, column names based on zero-based indexing. So our data are stored in the data frame and displayed nicely so that it is visually appealing. While we won't be using iClickers, excuse me, throughout this class, I wanted everybody to take a second here, think about this before we talk about the answer. So what does PD in PD read underscore CSV specify? Give you a second to read the answers. All right, now that you've had a second to look at these, if you didn't pause it, read through. I just want to make sure everybody's very clear. The read CSV method is from, or function is from the Pandas package, and we're using the shortcut PD. So C is the right answer here. So anytime you see PD dot, you know that that's a function from the Pandas package, and we're using PD as the shortcut to refer to that package. All right, I just want to make sure everybody's clear on these. Beyond CSVs, we've talked about JSON before, and this stands for, which I don't think I made clear in the last video, JavaScript Object Notation. Reminder, these are hierarchical key value pairings, and these, unlike CSVs that we talked about as lists stuck next to each other, JSON's a lot like dictionaries. So if we look at the information stored in dat.json, we can see that this looks a lot like a dictionary in Python, where we have a key and we have a value separated by a colon. Each key value pair is separated by a comma, and everything is within these curly braces. So this is what this small file looks like. And when I say it's like a dictionary, I very much mean that if you were to create a dictionary in Python and print that out, it would look very much the same as that JSON file. There's also a module for dealing with JSON. We'll go through this quickly. You can similarly use the JSON module to open a file and load everything in. And when you print the type of the information stored in DAT, JSON load will read it in as a dictionary type object, which makes sense. It's the most natural type of object within Python. As before, there is a helpful function in Pandas called read_JSON. Fewer parameters here, still a lot of flexibility. All of the parameters are explained in the documentation. So if you're ever unsure of a Pandas function, you can either Google it, the documentation online is great, or add this question mark after it, which will pull up the documentation, giving you information about each of the parameters. There are also examples at the end. So looking at examples, looking at documentation can really further your understanding when you're getting used to working with Pandas. So you can use the read JSON file, passing in this dictionary here as a series. And this will just orient it and format it in a little more visually appealing way, where we can see first is Alan and place is Manchester. Same idea for reading in a file. You can see this format is very much like when we were using the read CSV function. So we call the Pandas function, the method here, read JSON, pass it the path to the file name, and specify that it is a series type of object. This accomplishes the same formatting as when we pass in a dictionary. So again, JSON and dictionaries go hand in hand. XML, extensible markup language, again, stores tagged data. You can think of them very much like HTML if you're familiar with it. Same idea, we can cat C the file where we have these tags. We can use the DAT file to read in XML data. We can look at what that looks like. It is not very visually appealing because of all these opening and closing tags. CSVs and JSON are really great in working with pandas. Beautiful Soup, though, is a package that is much more versed in working with XML type data as it is built around web scraping and working with HTML. So rather than using CSV, anytime you have XML, I recommend using Beautiful Soup. And so from BS4, we'll import Beautiful Soup. Here we are just reading in that file. And you can see how it looks once you format it. So you have nicely parsed data, letting you know it's XML at the top, and then specifying the hierarchical nested way. Here we can see that who, what, and when is nested within person in a much more visually appealing way. So whenever you have XML or HTML, I encourage you to check out Beautiful Soup. We'll be using this in your third assignment. Now, I've introduced pandas as a way to read information into Python as a data frame. And this is because it is very, very helpful whenever you have heterogeneous data. So if you don't have simply all continuous variables and it's not going to work in an array, you're going to want to use the data frame object, which really is the core of the pandas package. And what a data frame object is a data structure for labeled rows and columns of data, which we just saw when we read in the CSV file. And it has a whole bunch of associated methods and utilities for working with data. So the way to think of this is each column contains a pandas series. So I said before to think of it as a list. The term for this list is a series in pandas, and a whole bunch of series stacked next to each other makes up a data frame. So we can read in a CSV file as we saw before. Again, pandas, read CSV, and then the path to the file as a string. And we're going to store that in df, which stands for data frame. You'll see this convention used a lot throughout Python. Now, I mentioned there are a whole bunch of helpful methods, one of which is head. Head will show you this nicely formatted data frame showing you the first 5 rows of your data frame. So these are the data we're going to be working with. There's an ID, a first name, a last name, age, a score, and a value. For the purposes here, it doesn't matter what each of these stands for. We just care about understanding this pandas data frame. What's important is that you recognize there is an index for each row. So the index for this first one will always be 0. And there's a column name for each column. Notice that when I read this in, I didn't say header is none. So we'll take whatever is stored in that first row in the CSV file and make those the headers. This allows us to refer to each column by its header name. And it stores heterogeneous types, right? So we're going to have values and quantitative continuous information. We'll have floats and integers. We can also store strings in a data frame, all in the single data frame, which helps when we have real world data. One important concept that everybody will need to be familiar with here is the idea of indexing and slicing. Here, indexing is what we're doing to slice, get all of the information in the last name column. So what the syntax here is we refer to the data frame, and then we use square brackets to specify which column we want and refer to the column as a string. So what this returns is all of the information stored in that column. So this idea of indexing is also referred to as slicing in Python, allows us to get information about a single column. So the same way you index into a list, you can index into a pandas data frame. So now with what we just talked about here, I have a question for you. Feel free to pause, check this out, add some code here. What would be the output of df age greater than 10? Okay, so I want to give a demonstration here. As I type this, df age greater than 10. This is going to return a Boolean. So a Boolean with true for rows where age is greater than 10 and false otherwise is the correct answer. Students often expect this to return the data frame, but that's not how this works. This is a comparative statement, so it's going to return a Boolean. If you want to get the data frame out, meaning the subset of the data frame where you only have those observations, those rows where age is greater than 10, you need to put that within these square brackets to index that part, to get that slice of the data frame. Okay, so this is a word of warning. This will return Booleans. It is a comparative statement. Those return Booleans. This slices that part of the data frame when you use the square brackets around it. Okay, so if you want the data frame, make sure you make your comparative statement to get the Booleans and then get that slice of the data frame using square brackets around it. Okay. Other information that's very helpful anytime you read in a data frame will be to get the attribute df shape. This lets you know there's 200 rows and 6 columns. Df columns will get you a list of all of the columns you have. So you can then change columns by changing and storing values back to this. You can check out the types of each of these objects. This will be very, very helpful, especially as you're working on your projects. Sometimes you might think something should be an integer, but it'll read in as an object, which is a string in data frame world. And that's probably because you have one or two places where it's a string rather than a value. So it's always good to check the types. So this is just the attributes stored in each of the columns. And you'll note that the types are maybe a little different than what you're used to. Int64 is Pandas' version of an integer, object is a string, and float64 is a float. Here, you can see I say that you can set the index to a string, something non-numerical, and use it as the index. These would be considered row labels. So for example, I'm now going to say whatever's in the ID column, set it as a type string, and I'm going to store that in the ID column. And then I'm going to use this set index method on dfid. And store that. So I'm going to change the indices from that 0, 1, 2, 3, 4, and so on to be the ID of each of the observations. So if rather than having 0, 1, 2, you want to be able to refer to a row by its index, you want to set it as the ID, this is how you would go about doing that. There are ways to control the column names, and there are ways to control the indices. We're going to have a whole lecture about exploring data, but I wanted to make sure to introduce the idea of quantitative. So these are continuous numeric values, qualitative, categorical, string-like values, and just basic descriptive statistics. Again, we're going to talk more about this in a video later. So you can always check categorical data using the value counts function. So if I want to know what first names come up the most, I can get the value counts. It will give me the output of how many times each individual names and sort them by the most common. So David shows up in this data frame 6 times, Michael 5, Eric 4, so on and so forth. Notice I'm just asking for the first 10. You can also check a particular descriptive statistic. So there are methods to check the mean and the median, the minimum and the maximum on a data frame. So if I wanted to get the average mean value from the value column, I specify that series and then ask for the mean, and that will give me the average value. I can also use the very helpful describe method, which will read out a whole bunch of helpful statistics on whichever series I specified. So here I'm asking it to describe information about the score. It tells me how many values, the average, the standard deviation, the minimum, the 25th percentile, the 50th percentile or the median, the 75th percentile, and the max. If you are unfamiliar with these descriptive statistics, we're going to discuss them all in a future lecture. Notice you can also get the descriptive statistics on all numerical columns. So there are more columns than what we have here, but we're only going to describe those that store continuous or numeric values such as age, score, and value. And you can get this very helpful column, very helpful table that gives you information about the numerical columns in your data frame. So here, what is the average mean age of the individuals in this data set? So you could write some code here. I'll give you a second. As you do this, remember you index in get the series, and then you can get the mean value here, which is 46.02. So B is the correct answer. You can also go up to this describe table, and you can see that that is the value stored in the table under mean for the age column. Just trying to orient everybody to how to get familiar working with data frames in Pandas. Okay, we're going to go over very common manipulations that you'll need to use for data in Pandas in the second of the videos in this series, but I wanted to take a slight detour to just talk about what APIs are, as some of you will be accessing them for your final projects. So APIs are a way for software to talk to other software. They are an interface into an application or a website or a database, and they are designed for computers and software to talk to one another. So even if two systems use two different processes and pieces of software, APIs allow them to talk to one another using a common language. This means that you can use your computer to get information from Facebook or from Twitter or from Google or from YouTube. All of these have APIs, and they allow you to, say, get data from them. APIs allow you to do much more, but this is likely how you would use them in the setting of a data scientist. A note on APIs is you have to follow their guidelines. Each API you use, if you go to YouTube, they are going to have different guidelines than Twitter. Make sure you read them and understand them. These guidelines are not like software when you download it and you just automatically click that you accept the terms and conditions. These you should read and understand what they require. They also typically specify the number, rate, and size of requests. Often you can get a bit of data for free and have to pay above some point. So it's important to consider that as you start getting data. Make sure you follow their guidelines. So for this example, we're going to use the GitHub API, and you can access the GitHub API from their API URL, api.github.com. And in this case, I'm just going to get information from my account, so user Shen Ellis. This API is open, so you don't need to specify who you are. Most APIs will require more stringent access to get information from it, so it won't be as simple as this example here. When you're requesting web pages from Python, I said anytime you're working with HTML, Beautiful Soup is going to be helpful, and so will requests to make the API request. So we'll import those. Note here, we're going to use requests get to make our call to the API, and I'm passing in the URL to what I want, storing this in page. Content is an attribute of page, so we can get back all of the information that we got from making this request to the API here, but it's not displayed in a particularly visually appealing and easy to use way. That said, what type or format of output is this? Great, so at this point, you should be somewhat familiar with the fact that when you see curly braces and key value pairs, this is JSON information. Often when you request information from an API, it will be in JSON format. So it's helpful to get to familiarize yourself with how to work with these types of data. Notice that, and here we don't need the import statement, you can read JSON in for page content, as this information was stored in a JSON format. And we can see this information. When we store it as a pandas object, we can see when we look at get data, the series object is very easy to interpret. We can see the login information is my information. We can see what the URLs to the gists, what my website is, where I'm from. All of this information can be accessed from the GitHub API. Now, it's not super interesting just to look at somebody's GitHub on its surface, but this is a way to, say, get information from a whole bunch of different people's GitHub and to get information to analyze, say, a set of Jupyter notebooks, which many people do. Okay, so an API allows you to make requests, get information from a website. Here I'm showing an example with GitHub. Many people use something like Twitter in this class to get tweets for their final project. I mentioned this, OAuth or Open Authorization is a protocol to authorize access of a user or application to an API. We did not use this for GitHub here as it was not required, but if I wanted to get any more information, GitHub would really require me to authorize who I am. This provides a secure way to log in without you having to type an account name and a password. It's a set of keys and passwords you can use to access an API. As a word of warning, these keys and passwords are for your eyes only. Never push them to GitHub, especially if they're attached to your credit card. People scrape the web, crawl the web looking to scrape these keys and passwords so that they can do whatever they want on your dime. So make sure you never push those to GitHub. I gave this very brief introduction to APIs, and we've talked about web scraping before, and you'll do this in an assignment. Web scraping and APIs are different approaches. APIs interface and interact with an application programmatically, and they're for systematic controlled access. You request something and you get that back, typically in JSON, a friendly data format. Web scraping, on the other hand, involves navigating through the internet programmatically following an architecture built for humans. So you have to delve into this messy HTML that makes a website beautiful to figure out how to pull out the pieces you want. It's hard to systematize, and it's dependent on the idiosyncrasies of the specific web page you're looking at. So if you tried to web scrape from car dealership A and car dealership B, you'll likely need different code to do it. And this will often return relatively unstructured data that you then have to force into a structured format, much more wrangling when you're working with web scraping, typically. Okay, so far we've introduced how to read information in using Pandas, touched on a few methods and attributes of the Pandas package. We've talked about APIs and web scraping briefly, and I just wanted to finish with a few notes about working with data. Data science is inherently ad hoc. I talked about this before with the idea of pure mathematicians liking that there's one solution and data scientists not having that option and having to be comfortable in the gray. There are no universal solutions. We have to figure out a way to utilize the data to understand the world better. And these data are everywhere, but relatively little of it was collected as data for you to analyze. So it's helpful to have these skills to figure out how to wrangle data. So what do we do in the world with the fact that data are all over the place? You have to think about how your data are stored and what its structure is. You have to look at your data before you analyze it. The last thing I want to see in this course is anybody writing a super complicated algorithm before they've even looked at their data. We're going to talk about missingness and outlier values and how to know whether or not your data are trustworthy. So my recommendations for now, before we delve into how to analyze data, is to prioritize using well-structured, common, open file types. And then you can utilize these tools that are developed to work with these types of data, such as Pandas. Follow common conventions. You don't need to reinvent the wheel. See what other people have done and minimize the workload on you so that you can just accomplish your goal. If you can't find data in a nice CSV, look for APIs. Ask if they're available. We're here to help. And know that web scraping is a complex and long task. You're welcome to do it, but only go to that if you can't get the information elsewhere. And think about your data flow from the beginning. It's helpful to think about where your data are, what format you need them in to analyze, and then set out a plan to accomplish that. Doing it in a haphazard way without a plan will just waste more of your time. So set up being well organized and have everything be labeled, give things good names, make sure your columns have good names, and think about when and how you might want and need to save out intermediate results. For example, if you spend a ton of time scraping information from the web, you should store that almost certainly in a file, maybe in a CSV, so that you don't have to web scrape every single time you need the data. With web scraping, this is particularly important as later on, the information may change on the website and how it's displayed, and your code might break. If you already have the data you need stored somewhere in an intermediate file, you'll be good to go. Okay, with that, that's the tour of working with and thinking about data in Python. And we are going to talk about more details about Pandas in the second Jupyter Notebook video in this week's notes. All right, I hope everybody is having a great week, and don't forget to take the Canvas quiz.